what surprises me is the Seabrook nuclear power plant took about 18 years to get through to build. They finally got it built, and there were, the people that said, "Oh no, we don't want that in our backyard," like you say. And now there's the alternative, which is the windmills, to make things, and everybody's saying the same thing. Like down off Nantucket Sound, they're trying to put that windmill farm in out in the ocean, and people are still complaining because it's gonna hurt my view of the ocean. Well, it's like, everybody wants power, so you got to do something.
Right. The people who are complaining are politicians who actually have power to do something.
Yeah. Yes.
I'll just give you, if you were sitting in your house, let's say you were one of those people, you were sitting in the house and you're looking out the window toward the Cape Wind Farm. Have you ever seen this? They did an illustration of what it would look like. That's what it would look like.
I think it would look cool.
Well, look at how small it is.
From the shore?
The point is, it's like, if you held out your finger and you held one knuckle up, that is how tall the windmill would look. It's not like it's 200 feet outside their house and then it goes up 300 feet.
Yeah, I think that's
it's 15 miles away. And this is what they're complaining about.
How many
towers look
They'd
worse?
rather have
What?
Cell phone
Radio
towers.
Yeah, they're much
Cell
worse.
phone towers too are uglier. But,
Right.
but so how many did they want to put up down there? I mean, what is the
Hundreds.
proposal?
I think there were hundreds of them.
Hundreds, yeah. I thought they wanted to put hundreds, and obviously the wind is perfect. I'm sure that's all been researched.
Right.
So
they keep pushing it further and further out.
further out.
That's what they're talking about.
Oh, okay. That's what the debate is now.
Yeah, well, they're trying to get it to where it looks like that. So that the pod, you're right. I mean, let's just be blunt. The Kennedys don't like it. They're the ones looking at it, and then there's a lot of other rich people out there that don't want to see it, and it's just.
But the farther you can't push it out too far because then it would be in shipping lanes, wouldn't it?
Right, and well, it costs a crap load of money to build a wire to connect it all the way to the land.
bring it all back.
Right.
Yeah.
So the hard part is just to convince people that all these things are worthwhile.
It is hard. Well, and that's kind of where we as an entity, if you can take away the upfront cost and let people, enjoy this. I've seen a picture of a guy talking about when he had his hands around it like this. And then other ones are huge, and they weigh tons. Yep.
Can you distribute this type of energy to many houses? Like saying we had another ice storm this year that we're without power for 2-3 weeks.
Could you build a system like this that would then
like
cover many houses?
Yeah.
Yeah, you could. But the utilities, it's very easy to do that. Like instead of having 15 generators, like my neighborhood, it sounded like a lawnmower convention when the power went out because everybody had their generators outside running. You could conceivably put one big generator at a subdivision and power the whole subdivision. The problem is that connection would have to be also connected to the grid. And so at the end of the street or something, there would have to be some kind of disconnect switch. And you would throw that switch and disconnect from the grid, and then you would start up the generator. Because the number one thing utilities never want to see is called a backfeed, where you're feeding power back into the grid. Because when the grid is down, the guys are out there working on it, they assume it's down. And if somebody's connected a generator to it and they didn't put the right switch and you're throwing power into the grid, they're going to go up there and touch that wire and you're going to kill them.
Well, that's why when you plug, if you have a generator at home and you plug directly into your box, you have to kill your main.
Yeah, you have to shut the main down, then you plug in the generator and start.
Yeah, if you do a transfer switch, you have to kill your main so it doesn't feed back up into the grid.
Right.
Same thing, right?
And we'll talk about when the microturbine goes in, it has multiple disconnect switches. If there's going to be a disconnect switch from the building, a disconnect switch between the building and the utility. The solar array has 3 of them, so that if one doesn't work, the second one will, and if the first and the second one doesn't work.
I got a question on that microturbine actually, since you mentioned that. Is that going to be a cogen operation where are you going to take the exhaust heat from that and make steam also, as well as making electricity?
We're going to make hot water, not steam.
Oh, I'm sorry, hot water, right?
Yeah, we're actually going to plug that.
Going to make hot water and electricity on that.
That's exactly right.
Okay.
And the electricity will always feed the building. The limiting factor on that microturbine will be the use of the heat. And so what we're doing, you have those of you that have been on the tour, you've seen the giant boilers. There's a return from the building and ascend. So the water, you know, let's say the boiler is set at 180 degrees or something like that. Whenever the water gets down to a certain level, the boiler kicks on to turn the water up, and then it sends the water through. And so, you know, the send is, let's say, 185, and the return is 165, or probably a little bit lower than that, 145. What we're going to do with the microturbine is we're going to plug it in here. And so we're going to take whatever the water is coming back and jack it up so that when it comes in, let's say it's at one, our goal is to keep this boiler constantly thinking that the supply temperature is coming through fine, and then the boiler will never turn on. If the microturbine ever can't keep up, like let's say it's 0 degrees out on a school day and everybody's opening and closing the doors and the buildings get too hot, the microturbine will work as hard as it can, but if the output temperature ever drops below that 170, this boiler will then become a backup system without even knowing it. It'll just heat up and send its supply. But as long as the microturbine can meet the heat demands of the building, it should be the only thing running. And so we're kind of hoping that we can get this turbine to run, well, we'll get it to run solidly for 7, 8, 9 months, depending on the weather. So if the next project here would be to get rid of this giant boiler. This thing's 6.5 million BTUs, which is huge. And the best part is that you have a second one sitting right next to it. So the total BTU output of the boilers down there is 13 million. Just for your house, your average house has probably a 75,000 BTU boiler if you're running it. So we're at 13 million in this building. This one's oversized, and then 2 of them is 3 times oversized. Now, the cool thing about the microturbine is it captures heat in 2 ways. You have the turbine itself, which is igniting, and there's a heat jacket around the turbine. And then the exhaust has a heat exchanger on it, and so it's actually capturing heat from 2 different locations in the turbine itself. And so your exhaust temp is actually really low, because not only are you doing it efficiently, but you're also running it through a heat exchanger. Yes?
Did you ever find out about the thrust?
The thrust? No, I haven't. The guy, he owes me 2 emails now. But I want to get him in here with all the materials and stuff.
My question to him was the day we took that tour, looking around, and we're in the boiler room, and I'm talking about the jet engine. It's an actual jet engine. It's got the vanes and the bliss all inside spinning. And my question to him was, what do you do about the thrust? Because those are designed to have air drawn in and pushed out with thrust. Where is that going? You know, it's one of those things that you think about. You know, you got jet engine. There's also other things that are being produced. No, I wouldn't imagine.
No, because we're using all the mechanical energy from the spinning to generate electricity. And so to connect it to a pump or something like that, you're talking about using the mechanical energy to run a pump. I think you could do that. The problem is this thing, it spins at such a high RPM level. You could gear it down probably. But believe it or not, the pumps down there are brand new. Next time we go through there, you can look. They're all very shiny and nice. Have all kinds of controls on them.
Shiny and
I think what I got from his question was to use the thrust to almost use a water-air mix to propel it through the school to get it to its destination.
Oh, was that what you were suggesting? I'm sorry about that. Probably not, because everything is so self-contained. I mean, if they were redesigning it, they probably could, but it's all entirely contained in a, you'll understand when you hear it. If it wasn't contained, it would sound really, really loud. And so everything's got to be completely encased. And because it's floating in an air bearing, there's a lot of air pressure in there sealed up. Don't want to put mechanical bearings on it, because then that'll create too much friction. Yep.